Apache Kafka is a distributed messaging system consisting of multiple nodes called brokers. Even small-sized production Kafka clusters require between 3 to 6 brokers. In addition, you need to deploy from 3 to 5 zookeeper nodes. Kafka uses zookeeper to elect a leader for the partition and stores configurations for topics and permissions. To start using Kafka, first you need to create a topic. Kafka topics are categories used to organize messages. Messages are sent and read from specific topics. The topic consists of partitions. Partitions are important because they enable parallelism, enabling high message throughput. More partitions topic has, more messages you can write and read from it at the same time. You can set the replication factor at the topic level for high availability. For example, if the topic has a replication factor of 3, the data for each partition will be duplicated across different brokers. Producer and consumer will use a partition that was elected a leader by the zookeeper. For our test, we'll use a topic with 12 partitions and a replication factor of 3. We'll configure producer to wait for acknowledgement from all replicated partitions before sending another message. There are 3 possible message delivery guarantees that could be provided. At most once, at least once, and exactly once. For this video, we'll use default at least once delivery option. In many cases, messages have a primary key. Receiving the data twice just overwrites a record with another copy of itself. Now, when it comes to gRPC, first you have to create a protocol buffer, message, and a service. You can compile it into different languages, which makes the protocol buffer a language-neutral mechanism for serializing structured data. The best part of it, when you need to send a request to the server, which can be written in any programming language. You simply use a function as you would typically use any other function in your code. Retries and load balancing is handled automatically by the gRPC framework. The size of the protocol buffer message is typically half the size of the JSON payload. Now, for the test, we use protocol buffers to send messages between gRPC client and server, as well as between Kafka producer and consumer. This is a very high-level test that aims to demonstrate what kind of latency you can get from each solution. Kafka has hundreds of different settings that can affect performance. In this video, we'll create EKS cluster from scratch in AWS using Terraform, then deploy Zookeeper and Kafka to Kubernetes, as well as producer, consumer, and gRPC server and a client. When Kafka receives the message, it immediately writes it to the disk and replicates it across different brokers. To improve Kafka performance, instead of using network-attached EBS volumes, you can leverage a static provisioner of local volumes and use local SSD disks. If you need to maintain a large Kafka cluster, it's better to deploy the cluster on the VMs rather than using Kubernetes. You can find the source code in my GitHub repo. Let's go ahead and run the test. Right away, you can notice that latency to send a message to Kafka and receive it at the other end is significantly larger than gRPC. And in this case, we deploy Kafka in a single availability zone. You'll never see such low latencies in real heavy loaded production clusters. 90% of the time, when you use Kafka, your use case requires using a messaging system, and Kafka is one of the best solutions in its class. Now, another 10% of the time, you don't really have a requirement for Kafka, but you still want to use it for whatever reason. At that time, if the low latency is important for your application, you may want to choose gRPC instead. Let's say you want to follow some best practices and deploy Kafka in multiple availability zones. It means every time Kafka gets a message, it must replicate data across different data centers. In public clouds, data transfer across availability zones can be very expensive. In some instances, data transfer can exceed your compute cost. Also, it significantly increases the latency. Based on my experience running large Kafka clusters in production, nothing happens at the same time for more than 1 or 2 instances. You may want to spend this money elsewhere or give a raise to your DevOps team. I have a playlist with other benchmarks that you may find interesting. Thank you for watching, and I'll see you in the next video.